going to do now is take a look at how you would calculate something called the percentage yield. And percentage yield is going to give us an indication of just how successful we have been in carrying out a chemical preparation. So we assume that when we start with a certain amount of chemicals, that using the molar ratio, that we'll achieve a certain amount of product. But how much product we actually get will always be a slightly reduced amount, and that will tell us what percentage success we've achieved, and we'll call that our percentage yield. So we can calculate it by doing actual yield over theoretical, so actual being how much did we actually get, over theoretical how much do we think we were going to get, and we'll work that out as 100%. So it's a bit like getting a percentage in a test. In theory, if you've done your revision, you should be able to get 40 out of 40, but actually in reality you might get 35, and you'd be able to work out your percentage, 35 out of 40 times 100. One of the key things we need to remember though about this is that these numbers in chemistry, the only thing that's comparable is moles, not mass, moles. So it's the actual yield in moles over the theoretical yield in moles. Remember, in chemistry we always convert to moles. Let's have a go and see how we can put this into practice. So it says ethanol can be oxidized to form ethanoic acid, and we've been given an equation here, a balanced chemical equation, and it's telling us some information. So it's telling us that we started with 2.3 grams of this ethanol here. And when the reaction had finished and we measured the mass of product, we got 2.01 grams of ethanoic acid, which is up here. So what we need to do is work out how much we would expect to theoretically get from 2.3 grams of ethanol. Now remember, in chemistry nothing is left as masses, so we're going to convert that into moles. So the first thing that you need to do is figure out what the MR is of ethanol. So pause the video and add up the MR of ethanol. If you've added that up correctly, you should have got 46, 2 carbons and 6 hydrogens and an oxygen. So the number of moles is mass over MR. So the number of moles of ethanol at the start of the experiment was 0.05 moles. Now then we're going to go to the equation and figure out how much ethanoic acid we think we will achieve then. Well, if we look, for every 1 ethanol, there is 1 ethanoic acid, so our ratio is 1 to 1, which means that the theory of quantities reacting is that the number of moles of ethanoic acid, which was this one, which would be this is our theoretical, would be equal to the number of moles of ethanol we started with. So in theory we should get 0.05 moles. How many moles did we actually get? Well, we can work that out by doing moles is mass over MR. So pause the video again and see if you can add up the MR of ethanoic acid. And you should have got 60. And we actually produced, if you look back, 2.01 grams. And the MR is 60. So if you divide that through on your calculator, you should get 0.0335. So what was our percentage yield? We actually got 0.0335. We hoped, in theory, to get 0.05, and we're expressing that as a percentage. That is coming out to be about 67%. So why did we not get 100%? Well, we could have lost some of our products during the reaction. So perhaps when you're transferring from one beaker to another, you'll leave some in the beaker. And also other reactions might be happening. If you're heating it up, some might have been lost by evaporation. If you're adding something that oxidises it, maybe some other reactions, maybe you get a bit of combustion, maybe some other reactions happen. So these are reasons maybe why you didn't get 100%. That's how we would calculate a percentage yield. So we'll have a go at another example. So our second example looks at the decomposition, and remember decomposing is just breaking down using heat, so no other reactants, into calcium oxide and carbon dioxide. Pause the video and see if you can write a balanced equation. That's what you should have got. And then if we look at our information, we've got 12.4 grams of calcium carbonate, and we're being told we're getting 90% yield, 90% conversion, and we're being asked to work out how much calcium oxide we've made. So how much calcium carbonate did we start with? Pause the video and add up the MR. What's the MR? You should have got 100.1. So we've got 12.4 over 100.1, 0.124. So in theory, given that the molar ratio is 1 to 1, in theory, so our theoretical moles of calcium oxide would be 0.124. But we've been told that we've only got 90% yield. How would you work out 90%? Well, 90%, 90 out of the 100 actually got formed, so work out 90%. So what mass is that? So remember that mass is Mr. Mole, so we're going to pause the video again and add up the MR of calcium oxide and calculate the mass. 6.25 grams. So 12.4 grams produced 6.25 at 90%. So you can see quite quickly from that you can't just use masses, because 90% of 12 is not going to be 6. So I want you to pause the video now and see if you can work through this example yourself, and then we'll have a look at the steps. So the first thing we need to do is use that 1.5 centimetres cubed and the density to work out how many grams of methanol we've got, and then use the MR of methanol to calculate how many moles of methanol that is. What you need to do now is work out theoretically, using the ratio from the balanced equation, how much methyl methanoate you think you should produce. So we were up to the point where we were working out the theoretical amount. Now the ratio was 1 to 1, so in theory we should get the same number of moles, and then we had to calculate the actual number of moles. Now, did you spot that you needed to convert from milligrams to grams and then express that as a percentage yield? The last little bit of this question then asks you, in order to ensure completion, the student uses 15% excess, given that that's its density, calculate the amount we would need for this reaction. So we're going back, we remembered that our moles of methanol, so just go back to bringing that back down here, was 0.0370. So what would be the theoretical amount of methanoic acid needed? Well, the ratio was 1 to 1 again, so in theory we would need 0.0370. We're using a 15% excess, so we're using 115%. Okay, we've got the 100% we need, that's the theoretical amount, but we want 115%, so the actual needed for a 15% excess, now you might have done at school just doing 1.15, where does that come from? It's 115% over 100 times by 0.0370. And if you work that out on your calculator, you should get 0.04255. Now that is our moles. So what mass would that be? So mass is Mr. Moles. So we're adding up the MR of methanoic acid. So you've got your 46, which is 1.9573 grams, and it wants a volume. So how do you get a volume from a density? We're going to do mass over density. You can always go back and look at density calculations if you need to practice this. So 1.9573 divided by 1.22, and you get 1.6 centimetres cubed is going to provide us more than enough. So this is quite important for a chemist to be able to work out how much we need and what will be enough.